Imagine a world where AI speaks 35 languages fluently. Well, that's exactly what the EuroLLM project is aiming for, and it could revolutionize how we communicate across borders.
That's fascinating. Can you tell us more about this ambitious project?
Absolutely. The EuroLLM project is developing multilingual language models capable of understanding and generating text in all 24 official European Union languages, plus 11 additional languages, including Arabic, Chinese, and Hindi. It's a significant step towards making AI more inclusive and accessible across Europe and beyond.
Wow, that's quite an undertaking. What makes this project so important?
Well, it's all about democratizing access to powerful AI technology. Most advanced language models we hear about, like GPT or Claude, are primarily focused on English. By creating models that work across so many languages, EuroLLM ensures people can interact with AI in their native tongue. This is huge for accessibility and inclusion, especially in linguistically diverse regions like Europe.
I can see how that would be valuable. What kind of real world applications are we talking about here?
Oh, the potential is vast. We could see these models powering everything from customer service chatbots to content creation tools, all operating seamlessly in multiple languages. Imagine a small business in Spain being able to communicate effortlessly with customers in Finland, or researchers from different countries collaborating on papers without language barriers. It's not just about translation, it's about enabling smoother cross-cultural communication and collaboration.
That does sound incredibly useful, but I imagine creating a multilingual model of this scale must come with its own set of challenges. What were some of the biggest hurdles the team had to overcome?
You're absolutely right. One of the biggest challenges was data collection and filtering. To train a language model, you need vast amounts of high-quality text data in each language. For English, there's an abundance of data available online. But for some of the less commonly spoken languages, finding enough good quality data can be a real challenge.
So, how did they manage to overcome this data scarcity problem?
Well, they got creative with their data sources. They used datasets like FineWeb for English and Red Pajama Data v2 for other high-resource languages. For the remaining languages, they combined data from several datasets like HPLT, MADLAD 400, CultureX, and MC4. But here's the kicker. It wasn't just about quantity. They applied rigorous filtering processes to ensure the quality of the data.
Oh, interesting. What kind of filtering processes are we talking about here?
They used techniques like deduplication to remove repeated content, language identification to ensure the text was actually in the intended language, and various heuristic filters to remove low quality or inappropriate content. They even used something called perplexity filtering, which essentially measures how surprised a language model is by the text. If it's too surprising, it might be gibberish or very low quality writing.
That's quite sophisticated. Did they use any other types of data besides web text?
Yes, they did. They also incorporated parallel data, which are sentences or documents with their translations in another language. This helps improve the model's ability to understand relationships between languages and enhances its translation capabilities. Using what they call joint scaling laws, they found that including about 20% parallel data for each language provided the best balance.
That's interesting. With so many languages involved, how did they decide how much data to use for each one?
Great question. They actually allocated 50% of their training data to English, since it's the most widely available. Then they distributed the remaining 50% among the other languages based on how much quality data they were able to collect for each. But here's where it gets really interesting. In the final stages of training, what they call the annealing phase, they decreased the English allocation to 32.5% and distributed that surplus across the other languages. This was done to increase the model's multilingual capabilities.
That's a clever approach. But let's talk about the actual model for a moment. How does EuroLLM compare to other language models we might be familiar with?
Well, the current version, EuroLLM 1.7b, has about 1.7 billion parameters, which puts it in the category of smaller language models. For comparison, GPT-3 has 175 billion parameters. But, and this is the exciting part, despite its relatively small size, EuroLLM is showing impressive performance, especially in multilingual tasks. The team compared EuroLLM 1.7b Instruct with models like Gemma 2b and Gemma 7b on various benchmarks. Interestingly, EuroLLM outperformed Gemma 2b on all language pairs and datasets they tested, and was competitive with Gemma 7b despite having far fewer parameters.
That's remarkable. It really shows the power of their approach to data collection and training. But I'm curious about the practical applications. How might we see EuroLLM being used in the real world?
Oh, the possibilities are endless. It could be used to create more accurate and natural sounding translation tools, powering multilingual chatbots for customer service, or even assisting in content creation across multiple languages. Imagine a small startup in Estonia being able to easily localize their product for the entire EU market, or a pan-European research project where scientists from different countries can collaborate more easily. It could be a game changer for cross-border communication and collaboration.
Those do sound like exciting applications. But I have to ask, what about the ethical considerations? We've heard a lot about the potential risks of large language models. How is the EuroLLM team addressing these concerns?
That's an excellent question, and it's definitely something the team is thinking about. While the paper doesn't go into great detail on this, they do mention that they applied various filters to remove inappropriate content from their training data. They also fine-tuned the model to follow instructions, which can help in controlling its outputs. But you're right to bring this up. As these models become more powerful and widely used, addressing ethical concerns becomes increasingly important.
So what's next for the EuroLLM project? Where do they go from here?
Well, the team mentions that they plan to continue training multilingual LLMs for Europe, with a focus on scaling up the number of model parameters and further improving the quality of their data. So we can expect to see larger and more capable versions of EuroLLM in the future. They're also likely to continue refining their data collection and filtering processes and possibly expanding to even more languages.
Certainly an exciting project to keep an eye on. The potential impact of having powerful, multilingual AI models that can work across all European languages is huge.
Absolutely. And it's not just about Europe. By including languages like Arabic, Chinese, and Hindi, EuroLLM could have a global impact. It's a great example of how AI can be developed with inclusivity and diversity in mind from the ground up. This could be particularly important for preserving and promoting less commonly spoken languages, which often get left behind in technological advancements.
That's a great point. Do you think this could have implications for language preservation and revitalization efforts?
Oh, definitely. By creating powerful language models for less commonly spoken languages, EuroLM could help keep these languages relevant in the digital age. It could lead to the development of more digital tools and resources in these languages, making them more accessible and appealing to younger generations. This could be particularly important for languages like Irish or Maltese, which are official EU languages but have relatively few speakers.
It's fascinating to think about the broader cultural implications of this technology. But I am also curious about the technical side. How does EuroLM manage to perform so well with fewer parameters than some of its competitors?
Well, a lot of it comes down to the careful curation and balancing of their training data. They've put a lot of thought into not just collecting data, but ensuring it's high quality and representative. They've also developed a custom tokenizer. That's the part of the model that breaks text down into smaller units for processing. Their tokenizer is designed to work efficiently across all the languages they're targeting, which is no small feat given the diversity of writing systems involved.
That sounds like a complex undertaking. How does their tokenizer compare to those used by other multilingual models?
Great question. They actually did a comparison with the tokenizers used by models like Mistral, Llama 3, and Gemma. They found that their tokenizer, which has a vocabulary of 128,000 pieces, provides a good balance between efficiency and coverage across languages. For most languages, it performs similarly to or better than these other tokenizers, especially for European languages. This efficient tokenization is part of what allows EuroLLM to punch above its weight in terms of performance.
It's amazing how much thought and research goes into these details that most users would never even think about. What other technical innovations did the team implement?
Well, one interesting aspect is their use of what they call grouped query attention, or GQA. This is a technique that helps the model process information more efficiently, especially during inference. That's when the model is actually being used to generate text or answer questions. They also used a particular learning rate schedule during training, which they found improved performance across the board.
Sounds like there's still a lot of room for innovation in this field, even as language models become more common. What do you think the next big breakthrough might be?
That's a great question. I think we might see more focus on making these models more efficient and environmentally friendly. Training large language models requires a lot of computational power, which has environmental implications. We might see innovations in training techniques or hardware that allow for more powerful models with less energy consumption. Another area to watch is the integration of these language models with other types of AI, like computer vision or speech recognition. This could lead to more versatile, multimodal AI systems that can understand and interact with the world in more human-like ways.
Those are exciting possibilities. It really drives home how quickly this field is evolving. Do you have any final thoughts on the EuroLLM project and its potential impact?
Well, I think the EuroLLM project is a great example of how AI can be developed with a focus on inclusivity and diversity from the ground up. By creating powerful language models that work across so many languages, they're helping to ensure that the benefits of AI can be more equitably distributed. It's also a reminder of the importance of open research in AI. By publishing their methods and releasing their models, the EuroLLM team is contributing to the broader scientific community and helping to advance the field as a whole. As we continue to see rapid advancements in AI, projects like this that prioritize accessibility and openness will be crucial in shaping a future where AI benefits everyone, regardless of the language they speak.